Assalamu alaikum dear students. Today the topic we chose is projectile motion. It is actually a projectile motion for class 11th students. So the dear physics students, please be attentive in this class, and I hope we will actually draw many things in this class. So get ready your notebook and a pen, simple pen, and keenly watch this lecture. I hope many things will come out and surface out, and we will learn many things in this lecture. So myself, Dr. Sajjad Ahmed Mir, Senior Lecturer of Physics, Government Boys Higher Secondary School, Pampur. So let us start. First of all, what is projectile? So then we will go to the projectile motion. What is projectile? So projectile is any object actually, or any body which can be thrown with some initial velocity, horizontal velocity, and then allowed to fall under the effect of gravity alone. I mean, other forces are neglected. You know, we throw something like this, we throw something in air, but giving some horizontal velocity, initial horizontal velocity, and then leave it to the gravity alone, I mean under the effect of gravitation only. So all other forces are neglected. If such is the case with any body, that can be referred as a projectile. Now in projectile motion we can teach you many things. The first of all, we will go to the projectile which is actually fired horizontally, I mean at zero angle with respect to the horizontal. There are many things, and we will teach you those things in parts. In first part I will go for the horizontal projectile, I mean which has been fired horizontally and making an angle of 0 with the horizontal axis, I mean with x axis. So first point में हम ये पढ़ेंगे, ठीक है, first part में, और next we will see what we can cover in this topic, but I hope we will wind up the whole things which are related to the projectile motion as far as the syllabus of class 11th is concerned. Now dear students, I will give you some more examples. Say suppose this is a ball, and this ball has been thrown upwards like this. What will happen? It will go up here, under the effect of gravity it will stop somewhere, the velocity, final velocity becomes 0, and then it starts coming back, from there. Okay, yeah, this is one type of the projectile where you have vertically launched a projectile. But somewhere if you will go the horizontally like this, you are somewhere throwing the ball, okay, in this direction, it will go and go on with the constant that speed. If air friction, whatever you have neglected, I have already told you all other forces we have neglected. So when we throw some object or body with horizontal velocity, it keeps on going because it's the Galileo law. There is nothing which will stop it if we will neglect the friction and other forces. Okay, so these are the two velocities. One is if another body is actually launched in between the two, like here, what will happen? It's not either we have not even launched it vertically or we have not launched it horizontally. So this is the velocity this time, it's obliquely, okay, obliquely fired like that. So then here it will be effect of two velocities. Here it will be Vx and here it will be Vy, okay, like this. So since when we launch this object, it will be considered under the effect of gravity alone, so we can refer it very well as the projectile. Okay, so let us stop it here. Now we will go to the projectile which has been hit horizontally. So projectile fired horizontally, okay, fired horizontally, okay, with some initial velocity, with some initial velocity, yeah, initial speed here, speed, okay, or velocity. Some initial speed has been given to the object, then it's actually left to the gravity alone, so we can very much refer it as a projectile. Okay, so the case will become like this. So suppose हम पहले वाले लेंगे, projectile fired horizontally with some initial velocity from some height, okay, from some height. Oh, ये वाला case हम पहले करेंगे. There will be many cases, but this one is the simplest one, so we will take as part A, okay, where we have actually taken the projectile which has been fired horizontally with some initial speed from some height. Okay, so the case is like this. This is projectile, okay, this is our ground level, and the projectile has been fired like this. When it has been fired, so it will go like this and hit the ground, so with some initial velocity. Suppose that initial speed is u, okay, and suppose this height is h. For example, this height is h from the ground. So from height h, it has been fired with some horizontal initial speed. So हमारा जो topic है, it has been now justified with this figure. Okay, so students, please take care, please be attentive in this class. So this is the projectile which has been fired horizontally with some initial speed and from some height. Okay, now let us try to derive many equations which will be very helpful in deriving the numericals. Okay, so let us go for that and derive those equations now. So first of all, so let me try to see what is the path taken by the projectile, whether it is a circular path, whether it is elliptical path, or whether it is something else. जब हम इसको पाथ, नेचर ऑफ द पाथ निकालने की कोशिश करेंगे तो वहाँ से हम देखेंगे विच पाथ द प्रोजेक्टाइल हैज़ बीन टेकन विच इज़ फायर हॉरिजेंटली विद सम इनिशियल स्पीड u. ओके, सो हम जरा पाथ, नेचर ऑफ पाथ इसकी देखेंगे. ठीक है, नेचर ऑफ पाथ, नेचर ऑफ पाथ. ओके, नेचर ऑफ पाथ क्या है, कैसी पाथ इस प्रोजेक्टाइल की होगी, दैट विच प्रोजेक्टाइल विच हैज़ बीन फायर्ड हॉरिजेंटली विद सम इनिशियल स्पीड फ्रॉम सम हाइट, इसकी पाथ कैसी होगी. सो देखिए ना, वो हमें, चूंकि हमें पता है, वी नो that projectile motion is an example of the two dimensional motion. तो यहाँ पर projectile क्या है, two dimensional motion किसको बोलते हैं, जहाँ पर आपको two position coordinates are required to determine the position of an object. So therefore this projectile motion, as the class 11th students know it very much, it is a two dimensional motion. It is a two dimensional motion. So let us know the relationship between the two dimensions, the two position coordinates, I mean x and y. So x axis is here like this and this is y axis. So let us try to find out a relationship between the two coordinates, two axes, and from that relationship we come to know whether the path is straight line, whether the path is circular, whether the path is I can say elliptical, whether it's parabolic. So everything will come out when we derive the equations. Okay, so what we need to derive? We need to derive a relationship between two position coordinates. Dear students, be now attentive. So relationship between two coordinates give us the type of the path followed by a projectile. You know, the path followed by a projectile is called a trajectory. So अब के बाद अगर मैं अब नाम लूँगा path of the projectile के बदले trajectory, you know the trajectory is the path of a projectile. तो हम देखना चाहते हैं कि the nature of a trajectory. So what is the nature of trajectory? Okay, so now let us go like this. So what we will do here, do you know that there is a this displacement coordinate, say like this, you know, equation of motion s is equal to ut plus half of at square. This is equation of motion for displacement. Everybody knows it from class 9th. So मैं इसको ना along x axis लूँगा. मुझे बताए इस equation of motion को along x axis अगर projectile के लिए लेना है तो हमारे पास क्या आएगी इक्वेशन. तो कैसी इक्वेशन आ जाएगी, देखिए अगर x एक्सिस पे हमारे प्रोजेक्टाइल ने जो डिस्प्लेसमेंट निकाली उसको हम x नाम देंगे. ओके, इसको हम x नाम देंगे. फाइन, तो अगर मैं इस डिस्प्लेसमेंट को x नाम दूंगा 2 मिनट के लिए, ठीक है. सो दिस इज द इनिशियल वेलोसिटी बट अलोंग x एक्सिस, सो ux t, okay, ux t, then plus half of this is acceleration along x axis and square. See students, be attentive please. So taking time constraint into the consideration, we need to wind up the things within 25 minutes or so. So therefore a few things I consider that you know from class 11th, from basics, so those things I will skip out here. So now we have equation. From this equation of motion, displacement along x axis, what is the displacement actually traversed by a projectile in x axis or along x axis. So that's s के बदले में x लूँगा. So u is ux, means initial velocity along x axis. This is time. So time is secular, it remains same whether you are going to x axis or y axis. So that's called the secular quantity. Okay, this is half. Then ax means acceleration along x axis, and this is time. So for your kind information, my dear students, you know we have thrown projectile is initial velocity u. So our ux is u. So therefore I can say x is equal to u into t plus, say like this, half of. Now ax is acceleration along x axis. Do you expect there is acceleration along x-axis? In projectile, remember it, there is no acceleration along x-axis. There is a uniform motion along the x-axis because this initial velocity remains the same throughout the journey of a projectile. Okay, so if it remains throughout the journey same, so the acceleration becomes 0. So there is no acceleration along x-axis. Okay, so therefore I can say this is 0. Okay, then t square. Why acceleration is 0? Because in x-axis there is a uniform speed, okay, when the uniform velocity. If the velocity is uniform, your acceleration come out to be 0. There is no acceleration along x-axis. Yes, there is acceleration along y-axis, because y-axis it's actually getting attracted towards the ground. It's under the effect of gravity, this gravitational effect, so it will always accelerate. There will be variation in the velocities along y-axis, but along x-axis we have neglected all other forces. There along x-axis there is uniform velocity, and thus acceleration 0. So this x comes out to be ut, then plus this whole factor becomes, this whole term becomes 0, then x is equal to ut. So this is displacement covered by a projectile along x-axis. X is equal to ut. So let us see what is along y-axis displacement, okay, because it is a two-dimensional motion, it has both displacements. Y-axis के related क्या आ जाएगी हमारी displacement, again using that equation of motion for displacement, s is equal to ut plus half of at square. Their displacement is y, s के बदले हम y लेंगे, that's initial velocities along y-axis, that's uy, time is same, it's secular, plus half of, there it is ay and it is t square, okay, right. So what you will get? You will get here y is equal to what is initial velocity along y-axis, because we have fired the projectile horizontally. There is no initial velocity along the y-axis. Initial velocity nahi hai. So this initial velocity along y-axis becomes 0. Okay, so 0 into t plus half of what is acceleration along y-axis. You know, it is always under the effect of gravitational force. Okay, because gravitational force you need to take into consideration. What is projectile? It's any object which is thrown with some horizontal velocity, and then it's left or allowed to fall under the effect of gravity alone. So gravity is taken into consideration, so it is accelerated with acceleration g, okay, that's acceleration due to gravity on the surface of earth. Okay, so now that's half of g anywhere, so g, okay, so this is t square like this, so this is y0 plus half of gt square. So now dears, look here, this whole factor becomes 0, this is 0 plus half of gt square like this, remember it. So this y is equal to half of gt square like this, okay. So now we have got two equations, here is first, here is second, two equations are here, okay, fine, two equations, we do have two equations now. So let us try to find out the relationship between the two position coordinates x and y. There is a one common factor, that's the time, that's why I call time is secular here, that's a common factor. So let's eliminate t in the equation number 2. That what we will do here, we will calculate here t is nothing but it's x by u. Look there, look here, so the x by u is equal to t, so we got here a t. So let's actually substitute this t in the equation number 2, and then we will be able to find the relationship between y and the x, I mean two position coordinates. So y is equal to half of g, and here it is x by u whole square, because we have substituted what? We have substituted that x by u is equal to t. We have substituted this from equation first, okay, from equation first we have substituted it there. So now what we will get? We will get y is equal to half of g x square divided by u square like this. Got dear. So I will show it here, because I'm running there out of space. So go move here. Let's move here. So my dear students, have attention here now. Y is equal to, it's g by twice u then x square. Okay. Look here. G is acceleration due to gravity, that's constant at any level, okay, then 2 is constant, you know, the initial speed, horizontal speed is constant, you know, this whole factor is actually constant, this whole factor is constant. So let us do like this, y is equal to kx square, okay, where k is equal to g by twice u. So we have got this equation. Is this equation y is equal to mx, is it actually resembling with that equation? If it would have been resembling with that equation, then we would have say that it is the equation of a straight line. But here you can look, it's y is equal to kx square. This is the equation of parabola. This is the equation of parabola. So therefore what we have got, what is the nature of the trajectory of a projectile? What is trajectory? Path of a projectile. What is the nature? It's parabolic. So we came to know, conclusion is this, that here I can put here conclusion that trajectory of projectile is parabolic in nature, okay. So this is our part first in this. So we have got the trajectory of projectile is parabolic in nature, and mathematical proof is there. So you will be now confident enough that the path of a projectile is not a straight line, it is not a hyperbolic, is not elliptical, is not circular, but it is parabolic in nature as per this is concerned. So we have got a mathematical proof for parabolic nature of trajectory. Let us now move ahead, because so many things will be required to solve the numerical problems. So therefore let us move ahead and try to derive other things for the same projectile. Okay, so I will rub it. I hope that you are noting down the things, because once you write down it on your notebook, it will remain with you, otherwise you may forget it with time. Okay, so dear students, once again let us try to derive the time of flight. Okay, what is time of flight? I will actually tell you, but time of flight, first of all let us go to the time of flight. Okay, what is time of flight? This time of flight is noted by capital T conventionally. Most of the books is denoting it by capital T. So what is time of flight? The time of flight is the time taken by a projectile to complete its trajectory. So the trajectory is the whole journey, because the time taken for the whole journey. So in technical words we can say it's a time taken by a projectile to complete its trajectory. Okay, time taken by a projectile to complete its trajectory. This is the time of flight. So let us try to derive how we can derive equation for time of flight, and then how we can calculate in many numericals time of flight. So for that, have a look, dear students, again. So we know equation of motion is there. The equation of motion is, say, S is equal to ut plus half of at square. Once again, you know that this is the equation for displacement. But along y-axis, if we will take this equation along y-axis, you know y-axis, our projectile has traversed a displacement of y. So displacement y along y-axis. So initial velocity will be uy, because initial velocity along y-axis, this is t, and this is half of, this is ay, means acceleration along y-axis, this is t square, like this. So y is equal to u by t plus half of a by t square. So initial velocity along y-axis and acceleration along y-axis. This is the equation of motion. The equation of motion, one of the equation, that is displacement along y-axis for our projectile, which is under discussion. Okay. So now, my dear students, look here, that if this time of flight, if we will consider t is equal to t. Okay, t is equal to t. So so let's first move the next step like this. So we can write y is equal to, okay, y is equal to, what is initial velocity along uy? What is initial velocity along y-axis? Because there is no initial velocity along y-axis, that's only along x-axis, horizontal, because that projectile has been fired horizontally. So this is 0 into t. Okay, 0 into t, then plus half of, what is acceleration along y-axis? That is g, as I told you, because acceleration is always along y-axis. There is no acceleration along axis. There is initial speed along axis, but no acceleration. There is acceleration along y-axis, but no initial speed velocity is there. So it is 0 here, sorry, it is g here, and then t square. What is g? Acceleration due to gravity. So we will get this equation, y is equal to, it is 0 plus half of gt square. Okay, once again like this. So y comes out to be, y is equal to half of g and t square, my dear students. Got it? But I am interested in time of flight. Here it is time, it is the general time. Okay, throughout the flight, but I am interested in time of flight, I mean the time taken to complete the trajectory of a projectile. तो हम ये ऐसे कैलकुलेट करेंगे. So if t is equal to capital T, I mean when time is equal to time of flight, time capital T is time of flight, then उस वक्त क्या होगा, हमारा जो y है, y हमारा h है. अगर हमने इसको h हाइट से थ्रो किया है, तभी हमारा टाइम ऑफ फ्लाइट के लिए, because it has been thrown from height h, so y is equal to h. So therefore we can write like this, therefore h is equal to half of g t square, capital T square. So here we are actually getting closer to get the time of flight. So it is twice h divided by g, that's equal to t square. So simple t square root both sides. So 2h by g is equal to simple t, because I have taken the square root of both sides. So t comes out to be under root of 2h by g. So dear students, this is equation with you. Okay, t is equal to 2h by g, under root 2h by g. So before you throw the projectile at some height, you can calculate its time of flight simply before you have started it, before the projectile started its journey. From the very beginning, knowing the only height from where you are actually projecting it, you can calculate in advance what shall be the time of flight for such a projectile. Okay, so this is the equation, T is equal to under root 2 h by g. So again move ahead, so we will go to the next topic, that is the range of a projectile. Okay, range of projectile. So next topic is range of projectile. I mean, I will write down range. So this is range of projectile. It's actually noted down, denoted by capital R. So this is the range. So what is range for a projectile first of all, and then only we can calculate it. The range is the maximum linear distance covered by a projectile, or we can say here it is the distance from foot of the tower to the point where it strikes the ground. So here its whole is range. This is range. Range is the distance of such a projectile from the foot of the tower to the point where it strikes the ground. Okay, so or we can say, in other words, it is the maximum linear distance covered by a projectile in time equal to the time of flight. जो time of flight होगा उस time में इतनी linear distance निकाली ना, वो उसका range है. So range कैसे calculate करेंगे? Once again I will make use of the equation of motion for displacement. S is equal to ut plus half of at square. So S is equal to ut plus half of at square. But here this time I will take along x axis. What shall it be along x axis? X axis पे क्या हो गया? तो it's the, see dear students, why I have taken only x axis, because the range is lying along x axis only, it's a linear distance. That's why we will take this equation along x axis. So here displacement along x axis, S becomes x, this is uxt, because this is initial velocity this time along x axis, plus half of this is acceleration along x axis, this is t square, like this. So this is the general equation, but along x axis what we have to replace, just initial velocity with the initial velocity along x axis means ux, and acceleration, but here it's acceleration along x axis. So how equation turns out to be now, so x is equal to, this is ux. What is initial velocity along axis? Look here, initial velocity along x axis is u, so it is u only. Okay, it's u, then t plus half of, is there any acceleration along axis? No, because there is a uniform velocity, so therefore acceleration becomes 0. As I told you already, there is the constant speed in the horizontal direction, so therefore acceleration becomes 0, but acceleration is only along y axis, and that too equal to the acceleration due to gravity. So now here it is t square, now x comes out to be ut plus 0. Okay, plus 0. So this x is equal to ut, like, okay, good, ut. We have got all earlier, we have got the same relationship, no problem. But हम यहाँ पर ऐसे लिखेंगे, if our time t is equal to time of flight, then जो linear distance x है ना, that becomes equal to the range. Okay, if our time is equal to time of flight, then x becomes range. So simply we have r is equal to u into t. Okay, so this t we have calculated just before a few moments, so u is equal to t के बदले हम लिखेंगे वही equation 2h by g. So the range for such a projectile becomes u under root of 2h by g. So got it, my dear students? So let's move to the another terms. So we have calculated the calculated the time of flight for a projectile, we have calculated the range of the projectile, even we have find out the nature of the trajectory of a projectile. So let's move ahead for other topics. Okay, now so what will the resultant velocity? What will the resultant velocity? In this class I will show you what is the resultant velocity. So it's at any point during the journey of a projectile on its trajectory, so it will have resultant velocity, the tangent to this trajectory, like this resultant velocity. So since it is a two-dimensional motion, we can disperse v into the two components along x axis and y axis. This is x axis, it will be vx component, and this will be vy component, like this. Okay, so let it makes theta with the horizontal direction, like this. Fine. So it can be a parallelogram, it's not triangle law, it will become a parallelogram law, like this. It will be parallelogram law. You know, in parallelogram the resultant velocity, now we are calculating the resultant velocity. Okay, resultant velocity. Okay, resultant velocity, the magnitude of that resultant velocity we can calculate like this. इसका magnitude हम निकालेंगे only. Okay, magnitude of resultant velocity, magnitude. Otherwise resultant velocity is this, v is equal to vx plus, ये vectorially है. Okay, vectorially we can write like this. Okay, this is vectorial resultant velocity. But magnitude जो है, magnitude wise जो है, magnitude wise, जब मैं magnitude wise इसको लिखता हूँ तो मैं ऐसे लिख सकता हूँ, v is equal to under root of इसका square, magnitude square, and then vy का magnitude square. Okay, like this. Since this will become a parallelogram law, and that too it is a rectangle. If we go 90, it's not a triangle, we can say a square plus b square plus 2ab cos theta, because theta there becomes a 90 degree and the third term becomes 0. We'll left with v is equal to under root a square plus b square, but a के बदले यहाँ पर है vx, b के बदले vy है, so we'll just write down v is equal to vx square plus vy square. So this will be the resultant velocity if we do have calculate, or else what we will do, we can use equation of motion. Like equation of motion, we know v is equal to u plus at. Do you know that? Okay, this equation of motion. Therefore अगर हम इसको along x axis लेंगे, along x axis, I mean x axis जो x component है वो मेरा मतलब है, so this becomes vx is equal to ux plus axt. Okay, so then vx is equal to what is initial velocity along axis, that is u, and this whole term becomes 0 because acceleration is 0, so 0 into t, so we will left with vx is equal to u, and now vy along y axis क्या होगा, along y axis my dear students, I will finish up within a minute. So this is vy is equal to uy plus ayt, keeping this equation into consideration. Okay, vy is equal to uy plus ayt, and then vy is equal to what is uy? Uy is 0 because there is no initial velocity along y axis. What is ay? This is g and t, so we will get vy is equal to gt. So therefore मुझे बताइए डियर स्टूडेंट्स, v किसके बराबर अब होगा, v इज इक्वल टू अंडर रूट, इसके बदले हम इवन u स्क्वायर लिख सकते हैं, और इसके बदले इवन g स्क्वायर t स्क्वायर लिख सकते हैं, इसका होल स्क्वायर है ना. So v is equal to under root of u square plus g square t square. This is it. Now if t is equal to time of flight, if t is equal to time of flight, that's equal to under root of 2h by g. Okay, you know we have calculated just now. So v is equal to under root of u square plus 2 plus g square and then capital T square, but capital T is v is equal to under root of u square plus g square. Here it is under root of 2h by g because time of flight is ka whole square, then it cancels out like this, and 1 g will go then with this, and we will left with v is equal to under root of u square plus twice 1 g here and h. This is the final equation for resultant velocity in case of a horizontal projectile. I hope that you have understood the things. Taking these time constants into consideration, I somehow keep that very basic elements, and hope you do have understood it. If you do have any question, then you can text me or drop a text on my WhatsApp number 9797012346. I repeat it, 9797012346. Thank you very much, my dear students.